Okay, to form up the rest of this, it's really quite straightforward. If you use the 2-point analogy, which is that any line has to have a start point and an end point. Now I know that the end of that line is there, and it ties up with there, it ties up with there. And the end of the next line is going to be tied up with that horizontal length there. Okay, and effectively this vertical height from the edge. Okay, so I'm going to measure on the outside of the grid of the shape that I've drawn at that point there. Okay, because I know that that's how far along the line will come. I'm going to draw a line in like that, and I know that it's going to taper in by this small amount here. I'll just measure this very small. Measure this size here and mark it on the line. It's that point there. And it doesn't rise up in the air at all. It doesn't go up in height at all. So that should be the point there. So this is the flat bit, characterised by that there and that line there. So just darken that in. Okay, now what happens? Well, when it gets to that point, it starts to climb up the way. Now, we know that it goes up a certain amount, and there's a certain amount there. We can measure that. But we also know that when it gets to that point there, it also tapers out. Okay, and the point that it tapers out to, you can get from just projecting down from that line there. So how high does it go up? Well, measure that from here. Mark that on the line. So it goes up from there to there, and then from there it goes all the way up to the top. Okay, so you end up with this shape here. Just turn all these lines in. Okay. Right, next thing we have to do is mark on where the hole is through the middle. Okay, so we can use drawing here to measure how far along. That should go on the surface here. And then basically, we draw down from there, where it intersects with that centre line is the point where the hole should be. Now, it's an isometric circle, it's an isometric hole, so we're going to measure the size of that, and we'll mark on the sizes here. Here, here, and here. Okay, so we know what size we're talking about. And we should really draw a little circle and then do some generators for it. So as careful as you can. Draw a circle, and then you divide it up using your generator. just in the normal fashion. Okay, going to be pretty small points obviously. So measure and mark these. It's very, very small. Points are very small. And just use your way, just measure the heights and mark the line. Okay. Once you get your points, draw your smooth curve. Okay, so there's your smooth curve there. Okay, and obviously that's where the axle goes, and it tells us in the question that the axle's in place. So what we need to do is basically expand out where the axle would be. Measure how long it is from the centre. You obviously need to do this on both sides, but it comes out quite far. You need to extend these lines a reasonable amount at the moment. I've done most of the hard work. You just compass in to where the start of the lines are, and you can just project the sizes round and move on to the next set. Next set of points. I'm just going to get it slightly longer so it's easier for me to tell which line is which. Okay, and then we just draw the tangent lines. Okay, when it's as small as that, you don't really need to measure the tangent point particularly. Okay, this is obviously going to extend out a wee bit more. Now, the more observant amongst you've probably noticed a deliberate mistake on my part. I've measured from the centre here out, and I've made the axle bigger than it is. It actually should be, strictly speaking, measuring from there and then out, should make it much shorter. I'm going to leave it at that just now. And I'm going to look at, if I was going to extend the other one out, then how far out would it come? Well, if it was, if I did it right, because I'm going to do this second one absolutely right, the top of it would be coming to somewhere about here. Okay, so I'll show you that in the next video.